Hi, I'm Rishil Guha from RV University, Bangalore, India. So today I'm going to present ApexGuard, a zero trust security and governance layer designed to protect multi-agent LLMs system from tool shadowing, capability injection, and high impact destructive actions. So now I would like to start with the demonstration of the website, which is fully deployed end to end. So as you see, this is the overview or the dashboard of the main page. So these are the agents which are available. There are almost 16 agents, which as you can see that there is the test block verify, demo test, and also you can, if you press on it, you can see that when they were used through the audit logs, as you can see, the reason was no rule matched due to this policy. Or you can see the test block verify where it has been allowed because it's rule matched. So, and you can also see that there are so many tools available for the agents: the read logs, list, get policy, modifying policies, and execute tools. So this contains all the different kind of policies all together with all the tools available, all the agents available, so that easily anyone could view what's happening, if it's getting blocked or allowed. And also it has the anomalies with with each block decision or allow decision, what has happened and which anomaly was expected or predicted. It also shows that. So as you can see, this views all the anomalies present. So the background auditor agent continuously scans the audit logs for abnormal behavior, repeated blocks, suspicious tool access, or attempted capability injection. All of these gets flagged instantly as anomalies. And now we will go to the policies tab. So as you see, there are several policies available. These policies are role-based access control or RBAC. Policies define which roles can access which tools and under which conditions. ApexGuard uses semantic versions for policies. That means the highest versions like 9.99 automatically becomes the active policy regardless of creation order. This ensures deterministic and predictable enforcements. So now we will go to the tool registry. As you see, there are different type of tools which we have already seen in the main dashboard. You can use it in simulator, or you can also see the examples. As you can see, this is the semantic way. The agent ID is present, agent role, the tool ID, tool version, the parameters. The tool tab shows the entire MPC tool registry. ApexGuard verifies every tool's authenticity using HMAC SHA-256 signatures. If a tool doesn't match its cryptographic signature, it's blocked before execution. So this is how ApexGuard works. So now, as you can see, this is the simulator. It has a built-in simulator. Hypothetically, agent actions would behave under current policies. Users can craft custom tools, choose agent roles, and see whether ApexGuard would allow or block them without affecting the live system. So now we would go to the one of the main parts of ApexGuard. So ApexGuard also includes an AI-powered policy generator using Google Gemini 2.5. Anyone can describe a governance rule in plain English, and Gemini converts it into structured RBAC policy with rules, assumptions, and test cases. This makes policy authoring accessible for security teams and non-technical stakeholders. So now we will like to see the example. As you can see, this is our AI policy generator. We will paste the policy in the box, and now Gemini 2.5 is working for generating the exact policy so that it can work through the Apex Guard, and the agent would recognize whether to allow it or block it. So, and also we'll try that in the dashboard whether the agent is allowed by passing on the script for different agents by creating the same name tool, but it should block as it's not SHA 256 verified. So right, we will wait for the Gemini to generate. So as you can see, Gemini has generated the exact policy. You can see that it has also come with the timestamps. So you can see it is 2024, 5th, 21. Agent guard policy description, and not even that, it has exactly given in the same semantic way. As you can see, the tool MCP read logs. As you can see, we had requested for the MCP logs with limit lesser than 10. And you can see there's ID, tool, test vectors, and the version 2. So now we would like to see the dashboard and let's verify if the audit logs work or not. So now we will pass on the genuine agent. So now I'll be using the script, and I have passed the script for the genuine agent through the terminal. So as we refresh the page, you can see that it has been allowed through the render allowed direct with the policy 9.99. And now we will pass on to the next command through the terminal, which shows that there's an agent with the same tool name, but it does not have the verification of the SHA 256. So now as we refresh the page again, you'll see that it's blocked because there's no rule match because it is not verified. So this is the ApexGuard. And now I would like to show you the architecture. As you see, this is the architecture which is also available in the submission of the Kaggle. This is the external LLM agents which have used reader agent, auditor agent, policy, and external. These are the tool registries. And the Gemini policy generator agents, which we have used NLP and structured policy JSON. And these are the logging layers, the databases which are used, the Apex Guard, policy stores, the dashboard UI as I've shown you, and the deployment layer which has been deployed end to end in render. And it might take 30 to 50 seconds as we have used the free tier in render, but it will deploy. And thank you for seeing the demonstration.